question is, what is that? Or just what's a proper fraction versus an improper fraction?
The numerator is smaller than the denominator.
For a proper fraction. Are we all okay with that? So instead of just the number being smaller, when we're talking about a rational function, we're talking about a rational function where the degree of the numerator is less than the degree of the denominator. So if we think about the different techniques so far that we've used for integration, okay, what are some of our techniques? Okay.
Integration by parts.
Okay, specifically I'm thinking about like if I have fractions. So like integration by parts is more like multiplication, so I'm wanting like rational expressions. So u sub would be 1, right? Because if I have like an x squared in the bottom and an x on top, I can use u sub. What are some other ones?
Long division.
Long division. Anything else?
Completing the square. Or I guess the quadratic formula would also be similar to that.
Not the quadratic formula. So when we complete the square, what do we end up with a lot of times?
Fraction.
Yeah. But we end up with like a perfect square plus something else, which most of those. It's a special rule, yeah. Which one is it?
The
Inverse trig functions, yeah. Are we with all of those?
Yes.
And that's our main ones, okay? Now, if I specifically have a proper rational fraction, do any of those no longer work? Which ones? Long division no longer works, right? Long division only works if my top is bigger than or equal to the bottom, right? But if I have a proper rational function, the top is smaller than the bottom, so I can't use long division. We agree? Okay, so that at least cuts out one of them. Completing the square and inverse trig are kind of related to one another. We're looking for stuff in that form of like a perfect square, or we could rewrite pretty easily in a perfect square. Agreed? What we're going to look at today is things that basically don't fit those, okay? So my top does not have the derivative of the bottom in it, so I can't use u sub. And it's also not going to look like two things that are perfect squares, so I can't use inverse trig. Yes, no, maybe. So what we are going to be looking for is a denominator that is easily factorable. Are we all with me there? Okay. So it says find the two partial fractions for the following. So let's think about if I gave you something like a plus b divided by 2. Can I break that apart? Yeah. What would it become?
A over 2. B over 2.
Alright. However, what happens if I have something that I have 2 divided by a plus b? Can I break that apart now? No, right? Because I would have had to find a common denominator and simplify and add them together in order to get something like that. Agreed? And so basically what we're trying to do is we're trying to look at something that is similar to this. I still want the two partial fractions that give me something like this, okay? But I can't just like say it's 2 divided by a plus 2 divided by b. Well, like I did say, it does have to be factorable. because, like we just said, if I go the opposite direction, right? If I add two things, okay, the reason that this top one works is because my denominators are the same. Agreed? Yes, no, maybe? Okay. What would my denominators have been if I'm looking at this example that I have of 1 divided by x minus 5 times x minus 2? If that's my common denominator, then what would have my two separate denominators have been?
X minus 5.
Okay, and?
X minus 2.
Cool. Alright, okay with that. So that's the first part of my partial fraction decomposition, is that I need to locate what my different factors are, which is why I said that we're looking for stuff that is easily factorable. Yes, no, maybe. Alright. Now, just the same way, okay, I don't know what my tops are, and so that's what we actually have to go through the process of finding. So we're just going to label those big A and big B. Okay, so far.
Yes.
Okay. Because like 98% of partial fraction decomposition just comes down to algebra stuff. So we just have to know the algebra. It can get a little bit long, but it's not super complicated. Now, pretending that this is which it is, a rational equation. I will solve rational equations. What's the first thing that we want to go for whenever we're solving a rational equation? Do we like fractions?
No.
No. So we want to get rid of said fractions, yes? So if I multiply by the common denominator, do I get rid of all of the fractions?
Yes.
Yes. And luckily, because I picked these two from my original, I'm just really multiplying by the denominator of your first fraction. Are we all okay with that? Yes? But it's an equation, so what I do to one side, I also have to do to the other. Agreed? So if I multiply my first fraction by x minus 5 times x minus 2, what am I going to be left with? Just 1. Okay. That's fun. If I multiply my second fraction, a over x minus 5 by x minus 5 times x minus 2, what are we going to be left with?
X minus 2.
Agreed. Okay.
B x minus 5.
Alright, I'm okay with that. So now, do we have a much nicer equation to deal with?
Yes.
Okay. Now, there are two ways that you can solve these types of equations. The first way is definitely the way, way more like mathy way. And that would be to distribute your A and your B. And then you're going to have to factor out some x's. And then you're going to have to set stuff equal to stuff that we have on the left-hand side. It's not complicated, but it's overly complicated for what we need. Or the second way, which is the way that I like, is we're going to pick x values strategically. Yes, no, maybe so? Okay. What might be a nice x value to pick? Why 5?
So make one of the terms 0, the other
Ah,
one
okay.
positive.
So if I make x equal 5, I get 1 equals, well now, 5 minus 2 is what?
3,
So I get 3a. And 5 minus 5 is what?
0.
0. So my second variable goes away. Yes? Are we all okay with that? Yes? No? Yes? Okay. So if I wanted to solve for a now, what would my a equal?
24.
Now if I wanted to do something similar with my other one, what would I pick for that one? What am I left with there?
1 equals -3.
Yes? So what does b equal?
1, 3.
Well, okay with that. Yes? No? Maybe? Okay. 1/3. Do we want a fraction over a fraction? No, so that's the same thing as multiplying by a third, okay? So we could also just rewrite it as 3 times x minus 5. Do we all agree that I can change my addition to subtraction because my b is negative? And then otherwise it's going to be the same. I have 1 divided by 3 times x minus 2. And this would be our partial fraction decomposition. I have decomposed it or broken it apart into partial fractions. 2 partial fractions. So was it as scary as the name suggests? It's not that scary. Maybe the first time around. It gets nicer as we go. Or faster, I guess. It gets easier as we go.
So why don't we like learn this before now? Is there any algebraic application?
I mean, similarly to like what we're doing with our integrals, as far as like we want to break it apart into 2 separate fractions. So if for some reason you're dealing with some sort of function, that it would be helpful for it to be broken apart into like subfractions, either for like simplification purposes or for like just rewriting it as different things. Partial fraction decomposition is actually in our pre-calculus textbooks. It's just one of those things that we don't generally have enough time for, and also you don't use it until you get to BC. So for our students that go to AB first or don't ever get to BC, like it's just kind of superfluous information for them. And like if we're gonna cut stuff because we're running out of time, then that's just one of the first things that gets cut.
That makes sense.
But now thinking about for our purposes, right? If I had the integral of this first thing, yes? I'm going to have x squared minus 7x plus 10 on bottom, right? Yes? So I have an x squared on bottom. I have a 1 on top. Could I use u sub with that? No, because my dx would just be a 2x, right? Which the 2 is not a problem, but I don't have an x on top to do my u sub with. I also can't use long division. That's also, as we can see, it does not factor to a perfect square, okay? So we can't take the integral of it with stuff up until now. Now, if I look at these 2 right here, can I take the integrals of both of these? Yeah, we're going to do a basic u sub, and we're going to end up with natural logs. Agreed? So that's why this is helpful for us when we're doing integration, is that it allows us to break apart fractions that we would not have been able to integrate previously. So, it says integrate by the method of partial fractions. So first things we want to look for is a 1, even if I didn't know anything, like that it didn't give me the directions to use partial fractions. What do we notice about that denominator? Yeah, is it easily factorable? Yeah. Okay. What does that factor to?
X plus 2 and x minus 2.
Yeah, okay with that. Movie. Now, I would say go ahead and we're going to come over to the side and do our partial fraction decomposition. Because if I try and do that within this, then you have to put your integral symbol in places and it just gets really funky, okay? So like, just come over to the side and do some side work with your fraction. So what do we know that this is going to have to equal? Okay with where we're getting our 2 denominators from? Yes, no. So then again, I would multiply everything by our common denominator. So x minus 2, x plus 2. On the left-hand side, just like before, we're going to end up with a 1. It won't always be a 1, but we're starting with a 1 just to kind of ease our way into it. On our second one, our x plus 2's would reduce. So what are we left with? Okay. And then on our B, our x plus 2's would reduce. Or sorry, x minus 2's would reduce, so we're left with an x plus 2. Are we all okay with that first step? Because again, none of the steps are necessarily hard, but we do have to understand where they're coming from in order to be able to solve properly. So then what might we do first? Cool. So I don't have anything to plug in on the left hand side, so it's just going to be 1. Equals, if I plug in 2, 2 minus 2 gives me 0, so my A is going to go away. 2 plus 2 gives us 4, so we get a 4B. Yeah, okay, so what does B equal? 1/4. Now, what would the other convenient x value be to pick? Negative 2. So I also get a 1. This time I have negative 2 minus 2 gives us negative 4. And then what happens to our B? It's 0. So we get that A equals negative 1/4. So now that I know that this fraction, right, can be broken apart using a 1/4 and a negative 1/4 with those, I can rewrite this. That's usually the most important step, is making sure that you don't do all of this work and then put the A and the B in the wrong places, right? Because that would suck to get it wrong for that reason. So my A is my negative. So I have negative 1/4 times x plus 2 plus 1/4 times x minus 2. Yes, no, maybe?
Yes.
So we could do u sub just from here, but we could also do we agree that that is a true statement? I just factor my 1/4 out to the front. Because it's constant.
Yep.
Yeah. Okay. So then on this first one, it is negative, which is fine. It's gonna mean that it's negative here. If we did u sub, what would we let our u be?
X plus 2
Okay. So du would be
dx.
and so we would end up with 1/u, which was the antiderivative of 1/u,
Natural log the absolute value of u.
which in this case we said was x plus 2. Okay. Would we get something similar for second one? Yeah. Because it's going to be a plus 1/4 natural log of the absolute value of x minus 2. And this is an indefinite interval, so I get a plus 2. Yes, no, maybe so. What questions do we have on this one? So far, so good? You ready to look at one that doesn't have a numerator of 1? Alright, so again, if I was just asked to integrate this. Okay, what would we let our u be? If I wanted to use u sub.
It's a numerator.
Okay, so what would our du be? 2x minus 7. Again, the 2's not a big issue because we could like right? And so then we would have like a funky 11 on top. We could try and like solve some stuff, but you would still end up with u's on top and u's on bottom, which is still not super helpful. But what do we notice about our denominator?
Factor.
It is. What does that factor to?
X minus 5 and X minus 2.
X minus 5 and X minus 2. We're all good with that. So again, good candidate for partial fraction decomposition. So I have and just so you know, it does not matter which order you put these in, right? Whether you put like the X minus 5 with the A and the X minus 2 with the B, or vice versa. As long as when you solve for A and B, right, like yours would just be flipped. So you'll still get the same numbers over the corresponding denominators, right? You would just have different variables than if somebody else had them flipped. Are y'all with me? Okay. So what is this gonna have to equal? X minus 5 plus. Alright, and then what would we do? Cool, so what are we going to be left with on the left hand side this time?
X minus 11.
So we do have an X this time. Okay, so it's not really going to change our process, but we are going to have to plug into that X. Equals, and we would be left with an A times,
X minus 2.
and then a B times,
X minus 5.
oh great. So what might be a convenient X value to pick first? 2. Alright. So like I said, the only thing we need to be careful about is we do have a 2 that we need to plug into on the left hand side this time. So 2 minus 11 gives us,
Negative 9.
okay. If I plug it into the right hand side, 2 minus 2 gives us 0, so A goes away. And then 2 minus 5 gives us a negative 3B. So what do we get for B? Positive 3. Alright. What would our other value be? 5. Okay, this time what do I get on the left hand side? Negative 6. 5 minus 2 gives us 3. And then 5 minus 5 gives us 0. So what do we get that A is?
-2.
Now, something to be careful about is that a lot of people will forget that when we set this up, right, we were decomposing it. So whenever I'm writing these out now, A is the only thing that is in my numerator. So I have X minus 5. Plus B is the only thing in my second numerator. Some people want to carry over this X minus 11 now that we have X's to begin with. But again, remember, if we found common denominators, we would distribute those 2's and that's 3's, and that's what's going to end up giving us the X minus 11. We don't need to carry it with us. Yes, no, maybe so. So can we take the antiderivatives from there? Okay, what do we get on our first one? Now, free response question, we are fine there. However, what is something that they might do, not saying that they will do it always, but they could potentially do on a multiple choice question?
Exponentiate.
Not exponentiate it.
Can multiply by the natural log. exponent or something.
Not exponents. I think you're on the right track though.
But like, cause like it's addition, so like each one's applied to inside each one.
So what can my 2 and my 3 become?
Or one.
Not quite. Remember that if I have logs, if I have numbers in the front, they can become exponents on the inside.
Yeah.
When you say exponentiate, that means to like raise those to the power.
An
Oh, okay.
exponential.
Oh, okay. Alright. And then our second one would be the same. However, we aren't going to multiply them because what does the first one have for exponency now? This has a what?
Negative.
Negative. So negative becomes what? When you subtract 2 natural logs, it becomes
Division.
division. So this would be the natural log of the absolute value of x minus 2 quantity cubed divided by x minus 5 quantity squared. Plus. Now, like I said, you would not be expected to do that on a free response question. Okay. And they're not even always going to do that on a multiple choice question, but you could see it for them to condense them. So I just wanted us to remind ourselves. Especially because like with these kinds, we end up with lots of natural logs because of how it ends up being when we integrate. Do you have a question?
Does the 5 minus x squared be an absolute value in the natural log?
Not in my first one because can x minus 5 quantity squared be negative?
Oh, no.
No, which is why I dropped it there because I was squaring it.
Would it be wrong if I put one
No,
there?
it's just redundant. So you're putting absolute values around something that's always positive. So like if for some reason the third power was like a fourth power, then I could have dropped my absolute values around the last part instead. But because the third power could potentially be negative, I would have a negative divided by a positive, which would be negative. So that's why in my final answer I do have to have the absolute values. But good question. But no, it's not wrong to throw extra absolute values. But just realize that they being like AP might drop absolute values if the stuff is always going to be positive. So just make sure that you can relate those two things together. Other questions? Ready to do one on our own?
Ready as always.
can't move.
You can't do fractions or algebra.
So then you could just swap the two.
So even if you're checking your answers, remember that your A's and B's might be flipped if
Oh,
they
okay.
wrote the other one first. So
Yeah.
just double check that.
There should be two.
But I wanna know the absolute value of X.
123 days.
I'm glad that you said that. Because I did think about that. As soon as I went into physics.
How many days we have left?
Yeah.
Which could be one and a half.
That's
Okay.
too long.
How do you just know that? That's like a third of it here, bro.
Literally. 4 months.
Unless we have the exact same thing.
Another ring of graduation. I can see that.
Yeah, me
I'm
too.
gonna cry.
Yeah, that's fine.
I'm just thinking about all the girls that are gonna get their heels.
Or not even, like, it's just money.
Yeah. But like,
Wait, is it
for
turf?
graduation, they get
Wait.
really high.
Wait, do we have turf?
Did you not give me?
Oh, so we might just be like squished.
I believe we get that B equals 1 and A equals 2. Again, they could be flipped if you wrote yours in the opposite with your X plus 3 being first. So A is 2. So 2 is X.
Oh, I just did the same thing that you did. I thought it was negative 6 plus 6 equals
We
6.
wanna try.
How'd you get negative 6?
See, because you can't multiply just by X. Because you keep saying that this comes in with 3.
It's 6, yeah, I mean.
And then I was literally like,
We should end up with 2 times the natural log of X plus absolute value of X plus the natural log of the absolute value of X plus 3. Again, we could also write this as the natural log of the absolute value of X squared times X plus 3. If it was a multiple choice question. Again, if it's an multiple choice, we aren't taking it further than that. I will say a lot of these, if it's just a straight up like integrate this thing, are going to be multiple choice and they're going to be non-calculator active. If it is a free response question, it would be more like if you're given some sort of application problem and then you have to integrate because of what the application problem is asking you and you just happen to have to use proper fractions here. Does that make sense? So, like you might have to do it within something, but like it wouldn't just be like integrate this thing for a free response question. Questions on that? Alright. We'll go ahead and stop there for today. We have one last one that I want us to look at tomorrow, and that's what we do when we have 3 factors instead of 2. So, but it'll take a little bit of time, so I don't want us to like try and crush it all here at the end.
Is that process